are getting back together, let's go ahead and get started going over this. Now, there shouldn't be any surprises here as far as what the right answers are. Again, I gave you the correct answers here, but sometimes just knowing the correct answers isn't enough to know what to do, right? Yep. If you need to, Sierra, but we are going over this, so if you have questions, be quick, all right? Okay, so number one, we've got a graph of f of x. Okay, the graph of f of x is cube root of x, and it's shown with point D there with coordinates 8, 2, okay, on the graph. F of x is then translated. Translated is just a fancier word of saying a slide or a shift, okay, to form the new function g of x. Okay, if g of x is f of x plus 2 minus 5, what are the coordinates of d prime, okay, for the function g? In other words, f is being transformed here, right? How is f being shifted? Left 2? Down 5. So we want to know then, where is d going to end up? If d is on the original function and we're going to shift everything left 2 and down 5, let's just count it out, right? Left 2, down 1, 2, 3, 4, 5. There's our new point right there. What's the coordinates? 6, negative 3. So it's b. Okay, that's simple.
Oh, really?
Easy peasy. Yep. Okay, number 2. The step function, graphed below, here's our step function, okay, shows the GPA score for a given percentage in a class. Okay, which ordered pair does not belong to the function? And I don't have it written out here. It would look something like, well, actually, I'm not even going to bother writing it out. Never mind. We'll just use the graph here, okay? So is 60, 1 a point on this graph? Yes, there's the x value of 60, and then there's the y value of 1, and that is a solid point there. So check. That one works, so it can't be that one, okay? We're looking for one that does not belong. Let's look at 75, 2. 75 would be halfway between 70 and 80. Does it go to a y value of 2? Yes, so not that one. C is 93. Here's 90. Oh, wait, there's a y value of 3. Does this point count? No, it's an open circle. We got to keep going. 90 is paired with 4. So this is the right answer. Okay, 100 is also paired with 4, right? 100, 4, you can see solid dot there, so it's not that one either. Okay, questions on 1 or 2? All right, moving on. Number 3, the table to the right shows the values of a function. Which best describes the type of function shown in the table? Linear. Okay, why do you say linear? Actually, no, too soon? No. Absolute value. What clues us into the absolute value here? All the negatives become exactly positive, right? You can also see another behavior here, right? We are decreasing and then start to increase. There's only a couple functions that both decrease and increase that we've seen. Exponentials, we have not seen both increase and decrease. Linear also does not both increase and decrease. Square root functions do not both increase and decrease. Quadratic functions do both increase and decrease. Absolute values do both increase and decrease, right? Quadratics look like this. Absolute values could look like this. Cubic functions are the ones we've seen do not both increase and decrease, right? So it can't be f. So it's either between d and e, and then you can look at the, oh yeah, all these are just positive versions, so it's got to be the absolute value there, e. All right, questions on 1, 2, or 3? All right, next. Number 4, Tomas is cycling from home to soccer practice. Tomas starts at his house and has a nice flat stretch of road for the first 3 minutes, and he travels at a speed. Okay, this is a lot of reading here. I don't want to read too much through this here. So let's let t represent the time in minutes of Tomas's trip, and d of t represents the total amount of miles from home. The graph below models Tomas's cycle. Okay? What kind of graph is this with all the little pieces here? It's piecewise, right? So if you look down here, you can see all these piecewise functions defined. Okay? What kind of functions here can we immediately cross out? Which one of these can we immediately get rid of? None of them. Sky? C. Why can we get rid of C? Yeah, all of our constraints here, all of our restrictions start at 0. But you can see here that our graphs don't all come out of 0. They start at 0. The first piece starts at 0 and ends at about 3. Then it goes from 3 to 5. And then it goes from 5 to 6. And then 6 looks like to 11. Okay? These all start at 0, and that can't be so. There's another one also all starts at 0. What else? Jackson? Yeah. Yeah, so D also has all these, so it can't be those, yeah. So it can't be D either. There's got to be A or B. Okay, now if you notice here, both A and B have 12t from 0 to 3. Okay, but then the second one is different. We have 4t here. We have 4t plus 24 here. for 3 to 5, right? So which one of these is right? 4t from 3 to 5 or 4t plus 24 from 3 to 5? So Hannah? Plus 24. Alessandro, what are you going to say? Yeah. Okay, yeah, the plus 24 here. Folks, if you remember, right, this is something that Jackson suggested back when we were doing our piecewise functions. This second piece right here, right, if you extend it back, okay, if you extend it back, what does it look like the y-intercept of this piece is going to be? About what? About like, yeah, between 20 and 25. What's the y-intercept for this second piece right here? It doesn't have one written, so it's 0, right? So it can't be this one. This one is 24. That's much closer to what the y-intercept would actually be, so it's got to be B there. It's got to be B, okay? Remember, you can also graph this on your graphing calculator if you type it in, right? Type that into y1, type that into y2, y3, and y4. But, you know, that's a bit tricky to type into. Okay, anyway, that's B. All right, number 5. Number 5, the graph of f of x equals the root square root of x and its image, g of x, are shown below. So here's f of x, that's the square root of x right here. And we got to figure out what g of x is. Which equation expresses the value of g of x in terms of f of x? Well, letter A. Can letter A be possible here? Letter A is saying that g and f are the same function. Do these look like the same function? No. Okay? Letter B. Letter B throws a negative in front of f of x. When we put a negative in front of our function, what kind of transformation does that result in? Reflect over what? The x-axis. Is g a reflection of f over the x-axis? No. So let's look at C. C could be it. Okay? And if you want to check it to make sure, I'll show you here. You can graph the square root of x, okay, and then I'll put a square root of negative x, right, because the negative is in with the x there. I'll put it in there and watch, graph it. There's my f of x, root x, and look at that. There's g of x, root negative x. And so what's the answer here? It's going to be C. It's got to be C. Okay? Number 6. Now we're going to describe domain and range. Okay? What does domain describe? What kind of coordinates? All right, looks like I need to volunteer someone to answer. Let's go to... Oh, Jasmine's not here. Lucky Jasmine. Jackson, domain describes what kind of coordinates? X or Y? X, very good. Okay, what is the leftmost x value in our graph here, Jackson? Yes, sir, good job. What's the rightmost x value here, Jackson? Infinity. Okay, thank you, Jackson. Let's go to Sierra. Sierra, what does the range describe? X's or Y's? Y's. Think alphabetically, Sierra, right? X comes before Y, domain comes before range. So domain goes with the X's, range comes with the Y's. Sierra, what is the lowest Y value it looks like our graph hits here? Yeah, so this is negative, I think, negative 2 here, but what do you see at the end? It's an arrow, right? And that means we're going to keep going down. So what's the lowest Y value going to be? There you go. Very good, Sierra. Sierra, what's the highest Y value we're going to hit? Yep, this point right here. Can you see what the Y value is on your paper? Okay. Can you see it now? Yeah, it's like 8. Just give me the Y value. Y coordinates, the second number. It's 5. It's 5. It's 5. You were going to say 5, I thought, right? 5. Okay, and then square brackets. Alessandro's out. If he comes back before time's up, then you can go. There's the range. Okay? All right, number 7. Okay, we're going to graph the square root of x plus 4 minus 2. We have transformations here. John, what kind of transformations do we see in number 7? Left 4, down 2. Put a point. Okay, we're going to create a table here. Remember, our normal squares are 0, 1, 4, 9, 16, etc. But all these have to be shifted left 4. So 0, if I go left 4, will be negative 4. 1 take away 4 is negative 3. 4 take away 4 is going to be 0. 9 take away 4 is 5. 16 take away 4, it's not going to fit, so I'm not going to do it. Okay? Then we'll go to our graphing calculator and find the matching Y values here, or you can plug them in, right? I'm just going to plug them in, actually, because I can do mental math here. Negative 4 plus 4 is 0. Square root is 0, 0. Minus 2 is negative 2. Negative 3 plus 4 is 1. Square root of 1 is 1. Minus 2 is negative 1. 0 plus 4 is 4. Square root of 4 is 2. 2 minus 2 is 0. 5 plus 4 is 9. Square root of 9 is 3. Minus 2 is 1. Plot the points. Negative 3, negative 1. 0, 0. 5, 1. And then connect the dots. Okay. Question? Yeah, looks like no one. No. Yes, you may go. Yes, go ahead. All right, that's number 7. All right, a couple more questions here, folks. Almost done. All right, so let's see here what we got. Number 8. Okay. Graph below, or to the right here, is of the function f of x equals negative 3, absolute value of x plus 2 plus 3. Okay. Can you see the transformations in it? How is this telling us how to shift? What? Left 2 and up 3, left 2 up 3. Hey, look, there's our vertex. And what's that negative 3 in front tell us? It's absolute value, so it tells us the what? The slope. Down 3, right 1. Hey, look, there's a point. Down 3, right 1, there's a point. And also down 3, left 1, down 3, left 1, right? Okay. What change would be seen if f of x minus 4 were graphed? What would this minus 4 do to our function? 4 units. Braden, is that what you're going to say? 4 units down? Yes, exactly right. It would shift this graph 4 units down if we had f of x minus 4 and we graphed that. Okay. So you could just count, right? I can just, like, from this point, I could go down 1, 2, 3, 4. That would be my new vertex there as an example. And I can use my slope to get more points. Down 3, right 1. There'd be another point. Down 3, left 1. There'd be another point. So it looks something like this. I know it didn't ask us to graph it, but I'm just showing it to you right there. Okay. All right. Number 9. Number 9 has several parts to it, so let's see what we can do here. Now, don't get confused with number 9, because there's a lot going on in this graph. Okay. You got to kind of, differentiate between the two functions we have here. Okay. We have f and g that are graphed. F is what kind of function? Well, how will we name it? What kind of shape is f of x here? It is a what kind of graph? Absolute value because of the v, right? What kind of graph shape is g? We just talked about these. Not piecewise, nope. Cube root. It's cube root, yep. So g of x is like a cube root, and then f is like an absolute value. Okay? So f of 7. Notice here, x is being replaced with 7. So on f, where's my x value 7? Right here, my x value is 7. But what's the y value, right? Because I want to find f of 7. So what's the y value here? Negative 2. That's right. Okay? Now for g, we're reversed. I have a blank for my x, and I have the y value. So for g, I want to find the x that gives me the y value of negative 1. So what's the x-coordinate for g that gives me the y value of negative 1 there? 3. Yeah, very good, Caleb. That's right. Nicely done. Okay. Letter C. If x is less than 3, so we're only going to look at x values less than 3. So forget about anything more than 3. I'm going to cover it up with my hand. We're only looking at x values less than 3 here. If x is less than 3, f of x is equal to g of x at point what? What's the coordinates where f is equal to g here? 1, negative 3. You got it. Good job. Now, why do I have to cover that up? Because there's another place where they're equal to over here, right? But we don't worry about that one. We were told for the x values less than 3. So please only consider x values to the left of 3. Okay, just that one right there. All right, letter D. Ooh, we got to come up with the equation for g. All right, how is g shifted here? How is g shifted? Okay, down 2. So where am I going to put that? Where am I going to put down 2? Where does that go? Which? At the very outside. And what number will I put there?
Negative 2.
A negative 2. Okay, how else is it shifted? We did the down 2. There's that. How much over? 2 to the right or 2 to the left?
2 to the left.
2 to the right. And so to do that, I have to do x minus 2. Very good. There's the equation for g. Okay. All right, let's talk about f. Okay, how is f shifted from its normal spot at the origin? How is it shifted? Okay, careful. There's the vertex. So it's shifted right how much? 3. So we're going to put an x plus negative 3 in there. That's weird they did that and put the x here too. So x plus negative 3. Okay, how much up or down? So down 4, so what goes in this blank? Minus 4. Okay, and then what about in front here? What's the slope of this thing? Yes, up from the vertex. Up 1, right 2, up 1, right 2, up 1, right 2. So yeah, it's 1/2. Good job. Okay, what's the domain of G? Negative infinity to infinity. Very good. What's the range of F? -4 inclusive to infinity, exclusive. Yep. All right, last piece here, and this one we need to do a little bit of work on. Okay, so I'm going to go ahead and do part B first, and then I'll worry about part A. Part A says write f of x as a piecewise function that does not include absolute value symbols, and then part B I'm going to graph it first. I think that's actually easier. So let's graph this thing. How is it shifted? To the left 3, so 1, 2, 3. There's my new vertex. And what does my slope tell me to do from here? Up 2, right 3. I'm just going to keep going. Up 2, right 3. Up 2, right 3. Up 2, right 3. And also up 2, left 3. Okay, and I'll connect the dots there. Okay, almost done. We got to write our piecewise function. Okay, now, we have not done something like that. Well, we've written piecewise functions before, but we've never taken an absolute value and broken it up. Okay? How many pieces do you think we're going to need here to describe this absolute value equation? How many pieces does it look like we'll need? Sky? 2. Alex, is that what you're going to say? 2 as well? Why 2? Sky, what kind of clues are we're going to have 2 pieces here? Yeah, we've got like kind of 2 separate lines. We have this line and we have this line, right? All right, so let's focus on this line here first, okay? To write the equation of a line, we need a slope and we need a y-intercept. What's the slope of this line, this part here? -2/3, right? Just count it out. Down 2, right 3, down 2, right 3. So we'll have -2/3 x, there's my mx. What's my y-intercept for this going to be? Well, we'll have to figure it out, won't we? So let's just keep going. Down 2, right 3. Down 2, right 3. What's my y-intercept? -2. So it'll be -2/3 x minus 2. There's my equation. All right? Now, for what x values is this true? There's where it changes, right? What's that x value right there? So it's at -3, right? So, and it's to the left of -3. What inequality symbol should we use to go to the left of -3? Less than. So we're going to say, comma, x is less than -3. Okay? Should I put it equal to here? I can, but I don't have to. I'll show you how we're going to do that here in a second. Let's do the other line. What's the slope of this line? 2/3, right? It's just the positive version. Hey, that kind of makes some sense, doesn't it? Because for absolute value, right, you have absolute value negative and then positive as well there, right? Anyway, what's the y-intercept of this line? 2. And it's for x values that go to the right of 3, so it's going to be x greater than, and we're going to do the equal to there. So here's the thing, folks. Just one thing real quick here. Either you put the equal to here or you put the equal to here. It doesn't matter which one you do it with, but one of them needs to have an equal to so you have it join up. Okay? Oh, it's -3. Thank you. Okay, and that's all, folks. Okay? Any set requests for tomorrow? Have a seat, please, till the bell rings. Brady?
Me.
Trey? Grayson? Any other set requests for tomorrow?
Can you pull me in on this stuff?
Yes.
Lauren and Alyssa.
I got you. All right, sorry. Here's what, Alessandro, yes? Okay. Grayson, have a seat, please. Here's who I have for set. Alessandro, Trey, Grayson, Alyssa, Brady, Lauren, and Braden. Anyone else for set? All right, have a seat, please, folks, till the bell rings. Have a seat, please. Okay. Have a seat, folks, till the bell rings.